like I'm explaining what's going to happen with the thing, and then
Woo!
do it, and then say, welcome to the Whoo from the MUSSEL Project. I am Dan Graff, Poet Laureate of the MUSSEL Project, here with Curator Emeritus Kevin Cummings, and we're going to talk about Lasmigona. Some people say Lasmigona, other people say heel splitter. Talk about Lasmigona and the cladomics functionality on the MUSSEL Project website, because I think that's a thing that's worth explaining, because I don't think anybody else is doing anything like that. So it's kind of
And
neat.
not many people know about it.
I don't think so. I don't think, we have a bunch of people that use it a lot, use the site a lot, or we have a few people that use it a lot. I think that's the way to do it. We get a lot of hits, but it's like from the same 8 people. So the muscle of the month this month is Lasmigona costata. There's the link to it on the home page. And the interesting thing, let's just go to Lasmigona, and I want to show how to use this functionality so people can use it. So I'm just going to go right to the database rather than you can read about the muscle of the month when you get to it. I'm going to go to Lasmigona, and rather than using this search thing, I never use that. I just go here to all genera, and then I would just find Lasmigona, or I could use my browser. Uh, Lasmi, here we go. Right, and get there. And what you notice here when you're on the MUSSEL Project website is that when you're looking at Lasmigona, it really lists only 3 species that are in there. And so, for example, one really common widespread species that's been called Lasmigona is Lasmigona compressa. And you'll notice that it's not on the list. And that's because based on the published phylogenies, like Lampsilus isn't monophyletic. And that's what I want to show how these data show that. So if we just back up one level right here to go back.
Lasmigona, not Lamsus. Go ahead.
All right, Lasmigona. Thank you. Thank you. Lasmigona, but Lampsilus isn't monophyletic either.
Right.
Lasmigona, if we back up a level here to the tribe that it belongs in, and you can see what we got going on here. Lasmigona is listed here, right, with its 3 species. And the other species that have traditionally been called Lasmigona, we have them here under Platinias. This is where compressa would go. And then Elasminota, which is an Ortman name. This is where like Halstonia would go. And what this is based on is just the fact that in phylogenetic analyses to date, Lasmigona is just never monophyletic. And you can see that here if we go, for example, and look at the cladomics page. And that the cladomics page gives a summary of the available phylogenetic data for all genera and all genus group and all family group level taxa on the website. It's just something, we have a database of the cladomic information, and then it's presented for each page. So I'll just kind of explain a little bit about that. There is the Cladomics FARC that's here that you can go to read more about what I'm saying here. The frequently asked rhetorical questions sort of leads through some specific examples and explaining some of the statistics that have been invented to try to explain this. But I'm just going to give you the gist right here, and you'll see what I'm talking about, that Lasmigona, heel splitters are not monophyletic, and that it makes sense that we can just split those out using existing names. So here we are at the top of all of the cladomics pages. It'll tell how many species are in this taxon. So in this group, the Elasmodontina, the tribe of Eastern North American anadontines, there's 51 species. And then it's sort of going to be organized around what you would call subtaxa, since we're talking about a sub-tribe in this case. So we're talking about the relationships of genera. That's what that explains. There's 15 genera in this, just so sort of explaining here's the scope of the taxon. We have 121 publications that have 204 cladograms with at least one member of the Elasmodontina, which would include Lasmigona. The maximum number of terminals, so species in an analysis, would be 33. So that's way less than 51, although the average number is about 4. So most of the time, these are just sort of being included as maybe not the focus of an analysis, but maybe outgroups or something like that, or some other part of the tree is the focus. The maximum number of genera that's been included is 13, but again, most of the time it's a lot less. And then it also gives some information about just the proportion of cladograms that recover whatever taxon we're talking about. Again, in this case, the Elasmodontina, how many recover them as monophyletic? And we break that out in two ways. So basic monophyly is just any cladogram that has at least two members of this taxon. What proportion of them find that recover them to be monophyletic? So it's about 80%, which seems like 84%, seems like a low number, but actually pretty good. Rigorous monophyly is where we have, in the case of then a subtribe, it has at least two different genera. So, for example, if some of these have two Elasmodontina because they have two species of Lasmigona, we wouldn't consider that to be a rigorous test of the monophyly of, or even approaching a rigorous test of the monophyly of the Elasmodontina. It really is a test of Lasmigona. So this is where we have more genera included. So about 80% in that case. These sort of statistics are provided for each taxon. There's some pairwise comparisons here. I don't want to get into those, but they're super cool. And I'm still trying to figure out how to make those things more meaningful. But here's the cladogram I want to look at here or show. There's a list here basically going through every cladogram that has at least one Elasmodontina on here. And it shows basically the part of the larger cladogram that includes those taxa. So if we just scroll down, there are lots and lots of cladograms here that have some Elasmodontina on there. They're going to be arranged pretty much, for at least for the purposes of this discussion, in order of the number of taxa that they have. So the ones that have the most sampling are going to be up near the top. And I want to look at this one here that Nathan Whalen and his group did in 2023, because this is the most comprehensive sampling for the Elasmodontina. And what you find here is, here's Lasmigona. Here's also Lasmigona. It wasn't recovered as monophyletic on this tree, but things like that happen. But what you find here is that Platanias, which is where Lasmigona compressa, subviridis, and those things come out, is down here, and Elasminoda is where you would find Halstonia and Etoiensis. So this pattern, if you scroll down this page, you'd see that this pattern holds up across analyses. Just all the rest of them don't have as comprehensive a sampling. That the genus Lasmigona, as you see it in most sources, just isn't monophyletic. We have actually these three different species groups that do tend to cluster together as their own groups, and there are existing genus names for those things. So on the MUSSEL Project website, we've already just gone ahead and updated the taxonomy in the database, and then when that happens in the database, it updates in the cladogram itself. So
yeah, it should be probably pointed out that these genera, Platanias and whatnot, were not the names used by Whelan.
no, they weren't on the tree. They just called them Lasmigona. Although in their paper they did go, it's not monophyletic, and you
Right.
could use these names. So they did.
They identified the names, but they didn't actually
They
place them.
didn't apply them. Yep. Yep. So this provides the basis for, let me just go back to where we were here, for keeping the classification up to date. And it'll also, because we're sort of preemptively just pulling together all of the cladograms for all taxa, it's easy to look and see and investigate, discover where there are these repeated patterns. So it isn't just Lasmigona, it's even the same analysis. We've broken up Elasmodonta into existing what were subgenera, elevating those to genera, just to make the data more consistent, to make the classification more consistent with the available data. So that's pretty cool. I mean, it's been an interesting tool to be able to apply to look at the sort of the history of phylogenetic work on a taxon and see are there consistent patterns.
So if you go back to the cladonomics page for Lasmigona,
Yep.
yeah. Can you explain what these these things at the top, ITBI, right under the
Yep.
publication there
Yep. Those are those. So the definitions for those things are
on that FARC?
in the FARC, so you can have that. So, right, and it's got to be short just so it all fits there.
Sure.
So it is IT is the number of in-group terminals. So in that
Okay.
case, the in-group in this case is Elasmodontina. So how many species terminals are present? So
Gotcha.
just if I click this link right here to the actual cladogram, like this is all unreduced and everything sort of with the number with the actual species that are there
Gotcha.
in this view, everything's going to be sort of collapsed down to whatever the appropriate level is. So in this case, within the in group, it's going to be genera. And then within the out group that's there, it's going to have those that are at the same level. So the other subtribes of the Anadontinae. So in group terminal species, this is the total number of terminals. Bipartitions is the number of clades basically that exist in the in group, so 34 clades. So it's an
Mhm.
indication of how well resolved they are. The rigorous in group subtaxa, so this is basically that's just so this is a subtribe, so number of genera in the analysis. Outgroup terminals, so that would be the number of species
Right, in the out group.
in the outgroup. Rigorous outgroup uh,
Same.
terminals would be the number of outgroups. So this gets kind of technical. So we could imagine having all these Elasmodontina and then a duck and a sea urchin and an oak tree. Those would be outgroups if those were in the analysis,
Right.
right? But they're not really testing, they're not really useful for this. By rigorous outgroups, we're reporting really the number of species that would actually be species within the same, in this case, tribe, but not in this subtribe. So
So
species,
there could be other out groups in this analysis that are not shown.
yep, right. So in this case, these numbers are the same because actually all of these outgrouped taxa are within the same tribe. So we kind of go back one level from subtribe, and then so things that are closely related. And then this is the rigorous outgroup subtaxa. So how many other subtribes within the Anadontinae are there? Two.
Two.
And then this last one there, this is the distance. So every tree here is, and by distance, we're using uh, a measure of how many taxa they have, how many terminal taxa are in common, how many bipartitions are in common. There's a statistic there that is explained on the FARC of sort of how to measure how similar one cladogram is to another. So these ones that have a more different topology are all being compared to the one at the top. So how different are they? Uh,
And finally, the thing in red there, the top monophyly cladogram in the RIS.
yep. So
That's the main one.
yes. So the tree that is the top monophyly cladogram, the one that is going to be the best one for really testing, in this case, whether Elasmodontina is monophyletic, is the one that's going to have the highest rigorous in-group sampling. So it's going to be the one with the most generous. So this is the top
That's
monophyly
13.
cladogram.
Yeah.
Yep. This one by Lopez Lima, it says, is the one that is the top sister group. So finding which cladogram will tell you what the sister group for the Elasmodontina is, and that's because it has the most rigorous outgroup sampling. So it also has both subtribes there. So this one also has two. This one
Right.
is preferred because it was published earlier.
Gotcha.
So it goes with the oldest one that has the most sampling. So, you know, in the case with Lasmigona, this is pretty straightforward. Lasmigona, in the old sense, is not one genus. It's three genera, and names already exist. sort of, I think where I would leave off with this is if we went here to Lampsilus and look at that pattern, what you can see here with this tree from Kentaro and his group is that Lampsilus isn't monophyletic. Lampsilus has Ortmanniana, Ligamentina, for example, nesting within that. And we have multiple branches here. We have sort of like this right here. This is Cardium is Lampsilus is the type there. We have Teres, which often it varies where it gets placed, would be another group within Lampsilus. Higgins eye, maybe that's an Ortmanniana.
Yes.
The Silicoidea group is yet another group. This is a pattern that's come up in lots of studies. Where's the one I want to find here? Here's this one from Stadola et al. You see that same pattern there, right? You have multiple groups there. But the thing is, Lampsilus, first of all, we've known it's not been recovered as monophyletic for a long time, since the 1900s of doing these analyses. But Lampsilus is so easy to recognize, and it has been for so long, that there just aren't a whole bunch of names. So there is a name for Terry's group, Simpunio, or Simpsonunio, you could do, I think that's what it's called. Uh, and but there isn't a name for the Radiata, Straminia, Silicoidea for this clade here.
So there appears to be four clades within traditional Lampsilus.
Yep.
We have Ortmanniana, the Terry's clade, the
Yep.
Cardia clade, and the Silicoidea clade.
Yep.
All of which have available names except, as you pointed out, Silicoidea.
Silicoidea doesn't. Yes. And so then that, I mean, that's real revisionary work then. That in my mind, that's where I would want to say, well, then that should be a thing that gets published, that gets anchored somewhere rather than on a website where things can just change
Right.
change them.
And that should be the focus of the paper, right?
I would
Revision
think so.
study of
I would
Lampsilus.
think so, but you could also, I mean, that's the thing is to fulfill the requirements of the code. I mean, you could just do it and then just go,
Sure.
oh, there's this clade and it needs a name. And how do I know that can be done? Because it's done all the time.
It is.
Time. I'm gonna go back to here to sort of point out at the end here. Let's go home at the dashboard here. I mean, we're over last year, I think it was, or maybe the year before, we went above 1,000 species, which was good because people for as long as I've been thinking about freshwater mussels have been saying there's 1,000 species, even though when we did our first checklist in 2007, there were only 840. But
Another fun fact about the dashboard here is many of the talks at FMCS last week always throw out the Eastern North America, the diversity capital of the world for freshwater mussels. When if you look at the dashboard there, East Asia has passed us in recent times.
yep,
So
yep, and it's been like that. I mean, so that was when we did the checklist. Partly we've changed. Part of that was changing how we defined East Asia. I mean,
sure.
uh, East Asia now includes what the Amur Basin and that which would have been part of Palearctic before. But even when you exclude those whatever 50 species that are in there, it still has that's where the real growth
Right.
in
A lot of the work is being done by Bolotov and people. And
yep,
so
right on. So hopefully that's a thing people can use. And so so kids out there, you want to fix Lampsilus? There it is. I just pointed it out. Go fix it. There are other examples on the website, and maybe we'll talk about those ones some other time or with some other uh mussel of the month. But I mean, it's there. Use
maybe
it.
next time we could talk about the links to GenBank records and whatnot.
I think that would be handy to talk about the vouchers that are there. That's ongoing work.
And
That's
how we have links in here to those actual
yeah,
records. That'd
yeah,
be good.
yeah. So yeah,
Stay
and then
tuned.
yeah, stay tuned. Yeah, there's going to be a button somewhere to like and subscribe on our YouTube channel here.
Not
And
lichens.
hmm?
Not lichens.
Not lichens, yeah, not lichens. Moss and subscribe. Uh, and maybe we'll make more of these if this drives some traffic to the website. Anything else we need to say?
I think that's it.
All right then. Well, thanks for tuning into the Woo from the Muscle
Muscle
Project.
Project. Woo!